Good afternoon, everyone. This is Paige. We had a snow day today, 1/21/25. So I'm just going to post this. We're going to do a little mini lecture, right? Online mini lecture, just reviewing some of our metric system stuff so that we don't lose too much time in our regular lecture. Uh, and again, we will go over this Thursday as well. Just wanted to get it out there so we could start practicing. So I'm going to do a little bit of review, right? So at the moment, we left off last Thursday with the metric system. I'm learning some of our prefixes, why we use it to convert to different units. So I won't dwell too much on the definitions. We went over these. I know you have them, so if you need them, look over them, right? So we have a system consisting of base units being grams, moles, liters, meters, right? Meters as well. And then we see here, oh, centi. So that's one of our prefixes. Centi is our prefix. So those are mainly what we're using. And then we will come down here, and I'm going to skip over our base units here because we're going to head straight to the metric prefixes. Okay, so these are them. There is a spot in your lovely little Unit 1 handout to write these down and start to learn them. Again, I would like you all to know from milli, which is 10 to the negative 3, all the way up to kilo, 10 to the 3. So there's kind of like 6 different prefixes that we got to learn here and how to convert between them. So if you haven't already, just start learning what they are so that when you see, oh, mg, you know that that's going to be milligrams, or you see hg, haha, mercury, but it's not. Hg would be hectograms, right? Grams slash whatever our base unit is, liters, moles, you know, it can be whatever you want it to be. So start learning those metric prefixes. But for now, we're just going to do a little review of how we move our decimals. So these slides are also, in our lovely kitty. Sorry, my cat is here. You can't see her. I wish you could. She's very cute. Little distraction. It's okay. Um, so, all right, moving decimals. See, look what she did. She distracted me. Moving decimals. What I was going to say is these slides will seem clearer when you actually download the PowerPoint, but I just converted it so I could make notes on it on my iPad, so it's a little bit blurry. Forgive me. But anyway, so we come to our unit timeline, and we have this lovely base unit here. So this has no prefix. 10 to the 0 is just 1, right? And we know that we can move either left or right. So when we go from a prefix, let's say we're moving from our base unit right here, and we want to go to milli, right? We're moving to the right. We're moving to the right. And our prefix is getting smaller. However, our original value is getting larger. Same thing the other way. We can start at our base unit here, and we could go to kilo, and we're moving left. So our prefix is getting larger now, right? Kilo is pretty large. It means 1,000. But our original number is actually going to get smaller. We did go through this lovely little example in class last Thursday. So I gave you 2.00 meters. I wanted it in millimeters, right? Which is 10 to the negative 3 right here. And we just used our kind of like bouncing decimals, our moving our decimals, right? So if I'm going from a base unit again right here to milli, that means I'm moving to the right by 3 spaces, just like it says up here. So move decimal 3 to the right. Amazing. And in that way, like we see, we have a smaller prefix, but the number is getting larger. So it also works the same way. If we are going from this base unit here, moving to the next example down here, this base unit is meters, and we want to go to kilometers. So we're getting larger. We are moving to the left on the timeline. And that is the same way that we are going to move our decimal, right? So we come down here, we go 1, 2, 3 hops to the left, and we will get our new value in kilometers, right? Kilo meaning 1,000, so 3 hops to the left. Now that is the easy way of doing things. What we didn't get to last Thursday was using dimensional analysis is also a way that we can convert between our metric prefixes. So moving down here, this is a timeline a unit timeline that I pulled from the internet that explains our metric system. So dimensional analysis, right? We're still starting here with our base unit of 10 to the 0. But this time, instead of moving the decimals, we're going to want to multiply or divide to get where we're going, right? So if I were to go from, let's say our base unit here is grams, and I needed to go all the way down here to milligrams, then I would be multiplying by a very large amount. So I would be multiplying by 1,000. 10 times 10 times 10 is 1,000. And so that's how I would get it. It's the same thing as saying, oh, I'm going to move my decimal 3 to the right to make that value bigger. You can do the same thing by multiplying. And it's the same the other way. So we can start at our base unit, right? If we're starting at grams and we need to go to up here to kilograms, in this case, right, we know that we could either move our decimal to the left and make that original value get smaller. But another way with using dimensional analysis is we divide. We can divide by 10, divide by 100, divide by 1,000 to get the same exact answer, right? So in this way, it's not just moving decimals, it's trying to cancel units, finding our equivalencies, and how do we cancel out grams to get to the desired quantity of what we want. So no specific example here, but kind of saying the same thing. So up here, it in this slide, it gives it to you, oh, times 10. So if you wanted to go from grams to decigrams, you would just multiply by 10, right? Grams to centigrams, you would multiply by 100 and then times 1,000 down here to get to milli. And so that is more clearly displayed on this next slide here, right? We start at this beautiful base unit, and we can call that grams again. I love using grams. And we can go, hey, oh, I need to get to milligrams. So that's where that is. You would have to multiply by, yes, Kitty, I understand. You would have to multiply by 1,000 to get that new value in milligrams. Just like going the opposite way, right? We look down here, we're starting here. We would have to divide by 1,000 to go from grams to kilograms. So we are going to do some examples of these. But first, there's two different ways that we can do dimensional analysis. So I'm going to go through these couple slides that were at the end of our very first PowerPoint lecture, right? So coming down here, two ways. The first way that we can do this is we can use our base unit, right, which is going to be whatever is sitting at 10 to the 0, and we can use that as a pass-through conversion factor. So instead of going straight from kilograms to, or kiloliters to milliliters, we can stop in the middle at plain old liters and then continue from there. Now, I find this way to be the easiest. I love using my base unit as a conversion factor because it usually comes, it's just easier for me to do it. Do it however you want. I'm going to teach you both ways. So we have an example here. Convert 7.34 kiloliters to milliliters. So we're moving bigger to smaller. We're moving from, as we can see if I scroll up a little, we're moving from right over here, kilo, and we want to get all the way down to the bottom at milli. So we're moving right. We know that. We are moving to the right, and our number is going to get bigger. So I just wrote these little, right down here, what they each mean. Kiloliters. Kiloliter means 10 to the third, right? That coordinates with the metric prefix. And 10 to the third is 1,000 if you took it out of your lovely scientific notation. And then we see milliliters. So milli is the opposite of kilo, 10 to the negative third. And instead of 1,000, it's 0.001, right? We get that, right? It's like 1,000, but moving in the opposite direction. So there's two different ways that we can do this. Of course, we need all of our units to cancel, but there's two methods. So I'm going to call this method A, and I'm going to call this method B. So method A, you're starting with 7.34 kiloliters, and you want to convert first to liters. So this is what I mean when we're using our base unit. I am putting it in liters before milliliters. I just think it's easier because the conversion factors are more consistent. So I know that for every 1 kiloliter I have 1,000 liters. I know that for a fact. And that makes sense, right? Because kilo is a larger prefix. And we know that if we moved right on our timeline to get from kilo back to base unit, we would have to move our decimal 3 to the right. So 1 kiloliter equals 1,000 liters. So that is how I set this up. I have what we started with, 7.34 kiloliters. And I use this conversion factor to cancel units. So like I told you before, whatever goes in the numerator, so right here, this should be the units that you want, which in this case is liters. And whatever goes on the denominator needs to be canceled out by our original value, right? So I put liters on top, 1,000 liters per every 1 kiloliter. That's the first step in the conversion. So after that, converting that, I have 7,340 liters. Awesome. Then I have to go back and I have to ask, well, hey, I'm at liters. What do I need to do next? Go to milliliters. So we're going to write another conversion factor here. And I'm going to say 1 liter equals 1,000 milliliters. And that makes sense again. If I scroll up a little bit and I look at this timeline, I'm going from my base unit to milli, and I am moving 3 to the right, okay? And that is also equal to 1,000. The number is getting larger. Our original number is getting larger. So I set it up the same way. I bring down my value of 7,340 liters, and I use my conversion factor. I know I want liters to cancel, so I put 1 liter on the bottom and 1,000 milliliters on the top, because that is what I want. I multiply it out, and I am getting 7,340,000 milliliters. That's quite a bit. But if you think about it, it's correct, right? We had to move our decimal. Another way to look at it, 7.34 liters, we had to move our decimal 1, 2, 3, 4, 5, 6 spaces. So 1, 2, 3, 4, 5, 6. Fill in your zeros and you get the same number. Wow, hooray. So I am just showing you that dimensional analysis is needed. We're going to be using it a lot, so it'd be good to get some practice in, but it's the same thing as moving the decimal. Now, there is another way to do this. So B, down here, right? These are just different conversion factors. So like I said, that 1 kiloliter equals 1,000 liters, we can also reverse that, okay? We can say, hey, how much does 1 liter equal in kiloliters? 1 liter. That's going to be the opposite of 1,000, 0.001 kiloliters. Cool, right? And then the same thing we can do again with milliliters. So we can say, oh, look, I have 1 milliliter. How many liters is this? Again, I remind you, to get from milliliter to liter, or vice versa, we are moving 3 decimal places. So if we think about the fact that we are moving to the right, I'm going to say, oh, I know, 1 milliliter is equal to 0.001 liters. So it's the same thing as A up here, but this time we are just switching up the unit like conversion equivalencies. So we can start again here with in B, 7.34 kiloliters. Of course, I want my units to cancel. I put kiloliters on the bottom. I know that there is 0.001 kiloliters per 1 liter. Multiply that out. Again, I'm getting 7,340. Bring that down, right? Because this is our base unit. And we're going to multiply it again, see if we can get our milliliters. So I have 0.001 liters for every 1 milliliter, right? So I'm dividing by 0.001 versus multiplying by 1,000. And at the end of the day, I'm getting the same number, 7.34 million milliliters. So that's kind of how it works, is there's multiple different ways that we can use dimensional analysis, right? So again, I come down here, these are the same numbers, but instead of going bigger to smaller, we're going smaller to bigger. So this time they want milliliters to kiloliters, right? Smaller to bigger. Again, I remind you of these equivalencies, and we come down to A and B. Very cool. And actually, you see that this time it's reversed. Spooky, right? So I say, hey, my unit path is going to be, I'm going to go milliliters to liters to kiloliters. So I have to figure out equivalencies. In this case, right, I am starting with a smaller prefix, and I am moving left on my unit timeline to get to my base unit. So when I move left, it's kind of the equivalent of multiplying by something that's smaller than 1, right? We're trying to make the original amount smaller. So I know that for this first equivalency, if I have 1 milliliter, how many liters is that? I know I have to move 3 to the left to get to liters on my timeline. So that would mean that 1 milliliter equals 0.001 liters. And we can apply the same logic down below, because I know I need to get to kiloliters. I can say, oh, if I have 1 liter and I have to move 3 to the left to get to kiloliters, then that probably means my multiplication equivalency is going to be 0.001 kiloliters per every 1 liter. So these are the numbers that we are using. So start here, right? We're back at the beginning. 7.34 milliliters times 0.001 liters per 1 milliliter. So now we have our units canceling. I'm ending with liters. And it gives me a smaller number than my original, which is what I wanted, right? Because we are moving left on the unit timeline. Bring this down, right? 0.00734 liters. Now I need to convert it to kiloliters. I have to move left again, 3 spaces. So again, I'm going to multiply. There are 0.001 kiloliters per every 1 liter. So my units here cancel out, and I end up with kiloliters. And so once I'm multiplying everything out, I get this very small number. God, what is that? 5 zeros, 0.0000734 kiloliters. And that makes sense, right? I started with an average number, but a very small prefix. And then it wanted me to go to a very large prefix down here. So it would make sense that my original number is shrinking. Okay, coming down here to B, same exact thing we just did. Also similar to what I told you previously, is that we can switch up these equivalencies. So we're going the same way, I'm just going to word it different. So in this case, I'm saying that I want my numerators both to be 1. So I have to figure out the equivalency. So 1 liter equals how many milliliters? We know this already, right? 1 liter would be 1,000 milliliters. We know that. And we can see that because when we go from liters to milliliters on our timeline, we're moving 3 to the right. 1,000. Wow, look at that. Okay, and then same thing down here. If I have 1 milliliter now, 1 milliliter, oh, that should be kiloliters. Sorry, that's a mistake. So this will be kilo. Hopefully I can correct that on the slides as well. I hope you weren't confused by that if you already looked at it. So that's kilo. So 1 kiloliter equals how many liters? Again, it's going to be 1,000 liters, right? Because I am moving to the left. On my timeline, well, to get from liters to kiloliters, I'm moving left, but if I go opposite, I'm moving right, which would give me 1,000 liters. Okay, so let's try this out, right? 7.34 milliliters times 1 liter per every 1,000 milliliters. I cancel these. And in the same way, I'm just dividing it out and I'm getting my smaller number, which checks out. I want it to get smaller. Okay, bring that smaller number down, multiply by 1 kiloliter per 1,000 liters. So again, my lovely units cancel, and I end up with my very small amount of kiloliters. So this is what dimensional analysis looks like. All right, that's what it looks like, is it's just using our equivalencies as conversion factors. La, la, la. So there is another way to do this, okay? This is the easiest method in my opinion because we are using this base unit, but there's another way, okay? And it's converting prefix to prefix. So let's say we start down here at kilo, right? We're starting at kilo and we want to go all the way to milli. Well, we can. And we don't have to stop in the middle here at the base unit. We can just go and we can use a million, right, as our conversion factor instead, multiplying by a million. Or the other way, we could go from milli to kilo, so we're going this way, and we could divide by a million and get the same number. And both of these would be correct. So that's awesome. So here's just a couple examples converting prefix to prefix, because if this makes sense to you, do it. It's less steps, right? So we got A and we got B again. So example, convert 12.3 kiloliters to milliliters. So we're going bigger to smaller. We are moving right on the timeline. And so that means our number is going to get bigger. Keep that in mind. If you're moving right, your number is getting bigger. Okay? So we have our equivalencies. I'm not using a base unit to go through. So I literally have to figure out, hey, if I have 1 kiloliter, like we do in example A, 1 kiloliter, how many milliliters does this equal? Well, I do know that 1 kiloliter to 1 liter will be 1,000. So I know that. And then I can go from 1 liter to 1 milliliter, and it would be another 1,000. Right? So in this case, look. Ooh, look at that. Look at that. 3 zeros. We're getting a million. Okay? We're getting a million. So 1 kiloliter is equal to 1 million milliliters. That's a lot. That is quite a big conversion factor. And so we can just plug this in down here. We start with kilo. We say 1 kiloliter is going to go on our denominator to cancel our units. And we multiply by that 1 million conversion factor. And that gives us 12.3 million milliliters. Amazing. Absolutely amazing. Love it. On the other hand, we can do the exact same thing and just reverse it, where we say, oh, I'm going to say that what I want in milliliters is just 1. How many kiloliters is that? So strange. So again, I know that going from milliliters to liters would be the same as 0.001. And then again, from liters to kiloliters would be another 0.001. Add those together, and what are we getting? Our big long number that we're going to use as our conversion factor. Very nice. So 12.3 kiloliters times 1 milliliter over 0.000001 kiloliters. Very nice. Very nice. Very cool. So these cancel. Our units cancel. I do my division. And again, since we're dividing by such a small number, our final number is going to get bigger. 12.3 million milliliters. Quite a lot, quite a bit, right? So that's kind of the gist, is that we can just use these very big numbers and get what we're looking for without using our base unit. And that's cool. That's very chill. There's another example here. My intention was not to make this video that long, but here we are. I'm going to skip this one. It's just the same thing going the opposite way, right? We're going the opposite way. So, coming down here, la la la, metric prefixes you must know. Just keep these in mind, okay? So, I have kilo, amazing. I have centi, and I have milli. So, definitely knows what these mean in terms of, hey, kilo means a thousand or 10 to the 3. Centi means 10 to the 2 or 0.01. And then milli means 10 to the negative 3 or 0.001. Opposite of, I should write that. Opposite. This is the opposite of kilo, if that helps you remember it all. So keep those in mind. And I'm thinking. I'm going to stop this video here, and then I'm going to make another video where we are going to go over some written practice problems I have. So watch this. Try to do what you must. There is a practice problem here with answers if you wanted to try it out, but I'm going to create some new ones and come back to you in the next video. So, au revoir for now.